everybody. Welcome to Germination's Retail Roundtable webinar, where we're exploring the topic of soybeans on the prairies today. My name is Mark Zinkowitz, and I serve as the editor of Germination, and today I am happy to be your host. Before we begin, I'd like to thank our sponsors, 2020 Seed Labs, Cantera Seeds, and SeCan for their support. As we go along, we invite you to share your thoughts and insight on Twitter using the hashtag SeedRetail. I also want to let you know that this webinar is being recorded and will be made available on germination.ca following the event. During the presentations, you'll likely have some questions for our speakers. Please type these into the chat box and we'll address them during the Q&A session that we'll hold after each speaker finishes. Today's first speaker is Elroy Cober of Agriculture and Agri-Food Canada. Elroy is a research scientist in soybean breeding and genetics, and he's worked at the AAFC Ottawa Research and Development Centre since 1996. His program has a focus on specialty food-type cultivars, primarily for the Asian export market. He works to understand functional seed traits which are important to soybean food producers. Elroy will talk about the history of soybeans on the prairies and some exciting new research. Elroy, the floor is yours.
Thank you, Mark. So today I want to review the history of soybean production and the spread of soybean in Canada. Secondly, talk a bit about the factors that control when a soybean variety will flower and mature. And finally, discuss choosing a variety that fits your farm, considering especially the yield-maturity relationship. So soybeans were recorded as first being grown in Canada in 1893. And the soybeans at that time were viney, ground-hugging plants with tiny black seeds, plants you can see in this picture, and they were used primarily for emergency annual forage crops. With World War II resulting in a loss of access to oil crushing facilities in Europe and a loss of oil import capacity from Japan and Northeast China, as well as a loss of access to other tropical oils from Asia, we had a deficit of edible oils in North America, and it started a push to grow and crush soybeans in the US and Canada to replace those lost plant oils. And this is what encouraged the oilseed soybean industry in Canada. The first Canadian oilseed production started in 1944 with the opening of Victory Mills in Toronto. This new market for soybean in Ontario encouraged production, and starting from 6,000 tons in 1940, probably less than 3,000 hectares, soybean production grew, as we see here, with statistics going from 1951 to 1996. So the first soybean production in Canada was limited to Essex and Kent County in the extreme southwestern Ontario. And then we see soybean production expanding out of southern Ontario in the mid-80s. And across those 45 years shown in this graph, there was a tenfold increase of soybean production in Ontario. Here I've got regional or provincial soybean production for the 2000s, and I've broken Ontario into southern Ontario, which is in black, where soybeans first were grown, and short season Ontario. Right now, soybean is the largest field crop in Ontario, and we note that the soybean production in short season Ontario overtook southern Ontario in 2013. The most dramatic change is the increase in western soybean production, and especially in Manitoba. We also see that Saskatchewan is now close to producing the same amount of soybean as Quebec. So from this short review of soybean expansion, I want to leave you with the message that soybean production in Canada for 100 plus years has been one of continuously expanding to shorter and shorter growing season areas. Soybean cultivars are regionally adapted. Individual cultivars moving north and south are primarily limited by day length responses and the season length. And as a result, we see these strips of adaptation, or what we call maturity zones, running east and west. Since soybean is a short day plant, it matures fastest in short warm days. And so moving north results in more delay because the days are longer. And we also have the second effect that moving north generally results in a shorter growing season. In contrast, then, we have wheat, which is a long day plant, where moving north speeds maturity because the longer days speed maturity and helps us fit into that shorter growing season. So in broad strokes, wheat cultivars have a north-south zone that's much larger than soybean cultivars. Since the soybean maturity map was first developed, we've added 3 more northern zones, so the 0, the 00, and the 000 zones. And the color map is a recent analysis where they've consolidated the soybean zones in the U.S. from an old range of 00 to 8 to a new range of 0 to 6. So what delays flowering and maturity, or what determines maturity in soybean? As I mentioned, soybean is a short day plant, and warm short days result in the earliest flowering and maturity. We had an experiment where we planted a range of early to late lines year-round in a greenhouse, and we were able to model then model the flowering time and determine what delayed flowering. So in our modeled genotype, and in this case it was a series of near isogenic lines where we had a common background and various early or late maturity genes were back-crossed into that background. So this was our series of genotypes that affected flowering time. Long days delay flowering, and if you are calculating your day, you need to consider the civil twilight, which is a little longer than sunrise to sunset. Low temperatures delay flowering. However, there's also a temperature by day length interaction, because we found that late lines would flower earlier in cool conditions compared to warm long days. There's also the rate of change of day length, which delays flowering, and interestingly, both increasing and decreasing changing days delay flowering. And for our conditions, we need to remember that the highest rate of change is at the equinoxes, so September 21st. Days are changing about 3 minutes a day there. And the final thing we noted was solar radiation. So low solar radiation, low amounts of sunlight can delay flowering, although it's most likely only an issue in very cloudy years or sort of maritime climates where there's a lot of cloud or fog. So genotype, or the genes that a soybean variety has, also affects flowering time. And this busy slide shows the network of genes involved in controlling flowering time in the model plant Arabidopsis. And in yellow, I've overlaid the known soybean flowering genes. So these genes have the potential to speed or delay flowering. And often there is a late or an early version of each gene. So you need to accumulate the early versions at a number of different genes to have an early maturing variety. We've got a lot more work to do in understanding the genetic control of flowering time in soybean. And as a result, we might be able to find even the earlier maturing soybeans. Photoperiod, or day length, has a large effect on the flowering time of soybeans. So this photograph illustrates that effect. On the left there's strings of 150-watt incandescent bulbs, and the plots under those bulbs are about 3 meters wide. The alley beside them is another 3 meters, and you can see the delaying effect reaching into that surrounding field about another 3 meters. So it doesn't take much light, and these were 20 hours that these bulbs were on, to have that effect on soybean maturity. So there are genes that will flower normally under these 20 hours, and so this nursery was to select for plants that would have normal flowering and maturity times, even though they were grown under these extreme 20-hour days. Maturity groups are used to describe both the zones of adaptation, so those strips that run east-west on a map, as well as an individual variety maturity, its relative maturity. And that describes where it is best fit. So this graph here is providing you the big picture of maturity genes and their photoperiod responses. So we have a collection of lines that are maturity group 00, that's the bottom line. That's sort of adapted to southern Manitoba. We have a maturity group 2, which is adapted to southern Ontario, maturity group 6, which is the southern US, and then the red one, the long juvenile one, is a tropical one from Brazil. So you can see that under short days, all the lines except the tropical one flower early and similarly. And you get the different responses, so the delayed flowering, as the days lengthen. So the idea is that we match the photoperiod, the maximum photoperiod where you are, to the varieties that fit best there. So to remind you of day length, Saskatoon has a maximum day of 18 hours, 25 minutes, and that's including civil twilight. Ottawa, where I am, is sort of about the North Dakota-South Dakota border, about 17 hours. So we need varieties that are sensitive to the changes in day length around the maximum, but not too sensitive. If they're too sensitive, they're too late. Next, I want to discuss matching varieties to the growing season, and particularly in this case, the relationship between seed yield and maturity. So all the factors that affect maturity are integrated in a specific variety grown at a specific location. So each variety has a specific combination of early and late genes. The planting date and the location determines the day length and the rate of change of day length, and your location and year determines the temperature. And so all of those factors are integrated into your yield results. And yield is what we're looking at here. So in this study, we grew Haro Soy, which is the latest maturing variety on the graph, and 19 other earlier varieties, isolines, that were developed by crossing in early genes. And this is showing the 5-year mean results for maturity and for yield. As a result of back-crossing in those earlier genes, we went from 128 days for Haro Soy to 97 days for the earliest isoline. And looking at the yield values at Ottawa, we can go from 128 days, which is Haro Soy, down to about 112 days without any yield loss. And then as we move earlier, the yield starts going down. Now, if we included some even later isolines, the yield would start dropping off as maturity got even longer because of the frost damage. So within what is considered somewhat adapted, the rule of thumb for the yield maturity relationship is about 30 kilograms per hectare per day, or a half bushel per acre per day. If we move further down that line, it gets even more extreme, so we start losing 75 kilograms per hectare per day. And then if we would move further right, so even later, the yield would start dropping back down again with the frost damage. So you can see why farmers always like to push maturity and go with a later maturing variety. If you get an open fall, you get rewarded with that higher yield. So your decision is choosing a late enough variety that maximizes your growing season while still having it mature reliably. You need to choose how often you're willing to risk yield loss from frost. So our earlier ones looked at isolines. That's a common background with different maturity genes back-crossed in. Here we're looking at some real yield trial results. So first up, the 2016 results from the Ontario Maturity Group 0, or the 2600 heat unit test. And the yield maturity relationship holds here as well. So choosing a full season variety is the simplest way to maximize yield for your farm. And when you've determined the maturity that you're comfortable with, look at the group of varieties around that maturity and pick a variety above the line if you want above average yield. Although while yield's important, it's not the only input into your decision. So varieties below the line might have a disease resistance or a stress tolerance package that you need. And since these are conventional lines, some of them might have higher protein that would result in a premium for an IP contract. So some growers will also give up yield and move earlier in order for their harvest to be completed earlier and allow for planting winter wheat. So yield is your primary consideration, but other factors are also important. Here we're looking at results from the Seed Manitoba 2017 guide with the Roundup Ready varieties. In this case, there's a little more noise because in Manitoba, not all the varieties are grown at all the sites. So in the 2017 report, the yield tables were broken into 4 maturity zones, but I included them all here so that you could see that full range of early to late maturity and see the yield maturity relationship. So the main reason to curb your enthusiasm for choosing a higher yielding, later maturing variety is fall frost. This experiment was carried out by Seth Nave at Minnesota to simulate the effect of fall frost on yield. They used 3 varieties, an adapted one, a late one, and a very late variety, with 2 planting dates, normal and the 3-week later planting. And frost was simulated with Liberty herbicide, simulating an early frost, a late frost, or no herbicide for a no frost control. The results are shown here for each variety, moving from the adapted to the late to the very late with the herbicide effect, so an early frost, a late frost, and no frost. And then on the left we have the early planting, on the right we have the late planting. So you see the yield advantage of early planting of late varieties when there's no frost. But with simulated frost, when we looked at the adapted variety planted early, there was no loss, but with the later varieties, early frost had a bigger effect on yield. And then if we look on the right-hand side where we have late planting dates, the yield losses are even more increasing with frost, especially on the later varieties. So this is the reason why you need to choose adapted varieties, to avoid the loss from frost. So when making variety selections for your farm, you need to start with a realistic maturity for your location. Then factor in your risk tolerance for frost, recognizing that you will win with a later variety in an open fall but lose with an early frost. Then look at that pool of varieties that are adapted within your chosen maturity. Avoid the temptation to look at those higher yielding lines further down the table. And also use actual days to maturity to judge your maturities. While yield's important, you have to remember to take other factors into consideration. You might need disease resistance or iron deficiency chlorosis tolerance, or if you're in an IP system, seed composition may be important for you. Canada has a long history of soybean expansion, going from southern Ontario to the rest of Ontario to Quebec to Manitoba and now Saskatchewan. Who knows how far soybeans can expand into Saskatchewan and Alberta. We have this balance between it being too dry in the Palliser Triangle and too short a season as we go north, but we really don't know how far north we could go. Okay, back to you, Mark.
Well, thank you so much, Elroy. If you have any questions for Elroy, please type them into the chat box now. We'll now have a short Q&A portion of our webinar. Elroy, can you sum it up for us? What are the top 3 factors growers need to take into consideration when choosing whether or not they want to grow soybeans?
I think first up, they need to think about whether they need to lengthen or diversify their current crop rotation. And maybe top of mind might be, do you have disease issues or disease potential in canola that might encourage you to lengthen your rotation? Secondly, do you have infrastructure for producing soybeans? And I'm thinking both you have equipment infrastructure and marketing infrastructure. And then third are the varieties that are adapted to your farm, to your region. So look for regional multi-location trial results there.
Now, if a grower decides that soybeans are right for them and their farm, what would you say the top few factors are that they need to consider in order to choose the best variety? Can you sort of recap that for us?
Yeah, so first off, you've got to determine what maturity you're comfortable with. So the season for your farm, your tolerance for loss to frost. Then when you figure that out, look at the pool of varieties that will fit into that maturity for you. And first off, look at yield. Then you've also got the other non-yield issues. So do you have possibility for iron deficiency chlorosis? Or maybe you need some herbicide tolerance traits for your cropping system. So thinking about what weeds or volunteers you might need to control in your sequence of cropping.
Now, I'm going to ask you to gaze into your crystal ball for a moment and looking ahead to next year, 2018, which is almost upon us, and can you make a prediction what you think the biggest soybean advance will be in 2018?
Well, I think the 2018 is sort of the potential of the combination of a bigger soybean acreage and an increase in the choice of varieties. So it was the new early maturing varieties that made soybean production possible in a bigger area, and then this bigger area in turn attracts the attention of variety developers. So it's maybe beyond 2018, but both of these things working together to expand soybean.
Thanks again, Elroy. Our second of three speakers today is Tom Warkentin. Tom is a professor and Ministry of Agriculture Strategic Research Program Chair at the University of Saskatchewan. He breeds field pea cultivars with an emphasis on agronomic traits, disease resistance, and end-use quality, but he's also involved in soybean breeding for the short-season regions of Western Canada. Tom, thanks so much for being with us today to talk about the future of soybeans on the prairies. You have the floor.
Thanks a lot, Mark, and thanks, Elroy, for kicking it off. Yeah, it's my pleasure to join this conversation. Do I advance the slides, or you're going to do that, Mark?
You're free to advance them, but I can certainly do that for you if you like.
Okay, no, I'll do it. That's good. Okay. Yeah, so I guess a question coming from the prairies might be, why grow soybeans in Saskatchewan or elsewhere in the shorter season prairie? And I listed a few things that came to my mind. One is that we have a need for more nitrogen-fixing crop options. Pea and lentil are grown fairly widely, some chickpea, a little bit of faba bean and common bean. But if you look at the annual planted area of crops in Saskatchewan, we're only at about 15% that's a nitrogen-fixing crop. So soybean could fit in there as another option amongst those N-fixing crops. We know there's large markets for soybean internationally. I see soybean as relatively easy to grow and harvest. Perhaps easy is stretching it, but easy maybe in comparison to lentil or chickpea, for example. Soybean seems to be fairly straightforward among farmers who have tried the crop. In recent years, we've struggled a bit with root rot in pea and lentil, especially in wetter seasons, and we know that soybean is resistant to for example, Aphanomyces, which has become an important issue in pea and lentil, and that's tied to the next point about soybean having quite good tolerance of wet soil. Typically on the prairies, it's on the dry side as it was in 2017, but we've had quite a number of wetter seasons in the past 10-15 years. And soybean, let's say in comparison at least to lentil and chickpea, has many herbicide options for weed control. So there's a lot of good reasons to try soybean, but there's a couple of reasons perhaps that could give growers concern or caution. And Elroy certainly talked about in general, soybean is a long season crop, so that's especially accentuated here on the prairie. It's somewhat drought susceptible. I think soybean's a crop that likes to have water in August. And in some ways, the seed's a bit expensive because most of the varieties are GM types that are grown these days, and perhaps in comparison to pea or lentil, seed cost looks a bit high. So growers need to balance those things off. So we have a young program here. I've been happy to work with Elroy over the last 5+ years to start a pilot project on soybean breeding for this part of the world. And so yield and maturity are the important field objectives, and then market quality would be protein, oil, and maybe food grade types. And of those, the one that's probably top of mind would be protein, because we know historically that protein levels in soybean tend to be a bit less in Western Canada than in Eastern Canada, and protein concentration is so important for soybean meal. We've had a trial for the last decade or more here in Saskatchewan to evaluate varieties that are being promoted by companies. And so I'm just giving you a summary of what will appear in the coming seed guide, so there's a sneak preview. There'll be 29 soybean varieties mentioned in there, coming from maturity groups 00 or 000, either having RR1 or RR2 herbicide resistance. For many of them, the hilum color is black, but some have yellow or incomplete yellow hilum color. They've been tested 2 or 3 years, with the check variety being the Thunder 33003. We've separated the yield for more southern parts of the province versus north, and the measured days to maturity range was 111 to 127. So when you see 127 or into the 120s, it's reason for some caution, because in some seasons we're going to have frost before getting that many days. Just for this season alone, good data were collected from 8 sites. I must mention that this trial was coordinated by Sask Pulse Growers starting in 2017. 2 sites were lost. Both of them happened to be in the south, so I'm encouraging them to establish a few more sites in the southern part of the province. But you can see the range of yields were quite respectable considering the drier conditions. And this slide further accentuates the fact that most of the Canadian prairie had less than 85% of average precip in this past growing season. A few pictures following to show you that soybean can grow in Saskatchewan. This one is from the Melfort Research Farm, where everything's always neat and tidy. And you see soybean here on August 14th. This is in our own nursery in Saskatoon later in August, where you see some of the early lines are coming to maturity, and others still have a little ways to go. This one at Kamsack toward the end of August, they're coming along fairly nicely. Here we are in Rostern at the end of August. You see quite a few of these are still quite green, but I'll point out that what's in the center of this trial is a trial, an experiment that was coordinated out of Quebec, and it has a range of maturities in it. Some of the material in that trial we wouldn't really expect that it will come to maturity in Rostern, but it's covering a big range, and it's part of a genetic study that's going to help us understand maturity relationships better across Canada. Here's one plot at Broderick, which is a site a little bit south of Saskatoon, where it's mature, but the plots around it are not. And here we are back at Kamsack on the 12th of September. So I mentioned being involved in a pilot project under the Growing Forward 2 project being led by Elroy, and I think that's looking promising. We're working to have a phase 2 of that project, and also a Genome Canada project that has broad goals to help us understand the genetic genomic aspects of yield and disease resistance, especially in short season regions of the country. So I guess maybe a take home would be that it's looking promising that there are some high yielding early maturing lines coming along, but certainly for Saskatchewan and western regions, a fair bit of research is needed, including breeding work, genetics, genomics, disease resistances. At this point, we grow soybean with minimal disease issues, but we know over time they will come. The physiology aspect that Elroy alluded to with temperature, photoperiod, we need to study that a bit more under the conditions of the prairies, and then end use quality. So there are many applications for funding on these topics. Maybe audience members who are part of selection committees, if you want better soybeans, please give these some consideration. So I think I'll just wrap it there, acknowledging sources of funding that are here. Many of these are for pea breeding, but some also now on soybean, and acknowledging collaboration with Elroy at Ottawa and ANFU at Morden, and many of my collaborators here. So I think I can wrap up with that, Mark.
Well, thank you so much, Tom. If you have any questions for Tom, feel free to type them into the chat box now. Tom, I'm going to ask you to do what Elroy did earlier and kind of look into that crystal ball of yours. And can you tell us what your verdict is on soybeans in Alberta? That's been sort of a hot topic for a while. And what do you see the future being in terms of soybeans that far west?
Yeah, well, there certainly is interest there from the researcher side and from some growers. I think so far the acreage is quite small. I would think it should fit in that irrigation district, definitely, where you can rule out drought. But I think it would have to be a compromise between picking soybean versus some of the other high-value crops that are currently being grown under irrigation. So I think in time, yes, soybean can be a good option there.
Can you recap for us, what are some major advances you see coming for soybean seed in the future, specifically now that 2018 is almost here? What do you sort of see coming down the pipe in terms of soybean seed?
Well, I think, the story that Elroy told of how soybean adaptation has moved from the southern U.S. into southern Ontario over a period of 50 years and now moving further north and west. I think that can continue in an incremental way, and just by conducting, especially I think by conducting the trialing, the breeding in these short season regions, we have a greater chance, I think, to pick material that fits best here. So I see a gradual continuation of that trend of going north and west with soybean adaptation.
Thanks again, Tom. Our final speaker of the day is Brad Pinkerton, Manitoba Marketing Representative for SeCan. Brad works with SeCan members in Manitoba to promote SeCan products. He provides technical support to members and coordinates local activities with SeCan's national communications strategy. Brad's going to talk about some common questions he gets from retailers and growers in regard to soybeans. Brad, take it away.
Okay, thanks, Mark. Thanks for this opportunity. So, like Mark said, he asked me just to talk about the questions I receive as a rep from retails, and just spend 5 or 10 minutes talking about those types of questions and how we deal with them at SeCan. And so, of course, the first thing is everybody always asks about maturity, and no, I'm definitely not very mature. Everyone's always asking about yield. How does your variety yield compared to XYZ? And of course, it's hard to have a direct comparison to every single variety out there at your fingertips, but that's a common question we get. On some years, like 2016, we get a lot of questions about white mold. There's a lot of sclerotinia pressure that year. This past year, 2017, lots of pressure with iron chlorosis, so there's lots of phone calls on how your varieties tolerate that stress. Some years we get a lot of questions on phytophthora root rot ratings, and some areas, mostly in western Manitoba and into Saskatchewan, we get some questions on pod height. We don't usually get that in the valley here, the Red River Valley. And as I get these questions, I'm always challenged with, okay, what sort of information do I want to push back towards whoever's asking the question? Because everybody has different levels of acceptability for different types of information. As a rep, I'm looking for a certain kind of data. As a salesperson, you're looking for something different. And as a farmer, you may or may not find the same data acceptable that I might. So more and more what I hear from both retail and farmers is, private data is always biased. Even though I'm hiring out third-party research people like AgQuest and Keith Murphy to do my trials, my yield charts are always seen as most likely biased. Every company has the best products. So more and more I choose to use yield data from third-party places like Seed Manitoba or Saskatchewan Seed Guide, because farmers really see that as the best data. And so whenever I have an option, I'll try and use yield comparisons from that book versus my own private data. I find retail field fact sheets are good. They describe characteristics of varieties, but the key for both farmers and retailers, I think, is they really want to hear, how did other farmers do? How did the product do on other real farms? They want the testimonials, and we always have to caution that, because just because one person had a great experience in one area doesn't mean that variety is a winner. It doesn't mean it's going to perform all across Manitoba and Saskatchewan and everywhere. So we really need to find multiple testimonials, multiple experiences, and lots of different environments to really start to gain some sort of comfort level. And of course, confidence, comfort level, that's what we're looking for. That's what we want to be able to sell our products to farmers. We want to feel comfortable and confident in these new products. And man, every year we're getting more and more genetics. I've spoken about previously today already that there's lots of new stuff in the pipeline. I just got a few new varieties today from Monsanto, and so we're constantly having to look at these new products and try and build some confidence in them. And so what I've found over the last number of years is it takes me about 2 years, or takes my retails about 2 years to really build enough confidence that they can go out there and happily sell that product with a lot of comfort. And so what do we do to try and help build that confidence or comfort level? And the first thing, of course, is myself as the rep. I need to believe in that product. So for me to believe, I still run about 4 or 5 locations of replicated trials, so that I can get out there, spend lots of time with these new genetics, side by side, ones that I feel more comfortable with. And I'll get my feet on the ground in lots of seed fields in lots of different areas across Manitoba and Saskatchewan. And I depend very heavily on testimonials from my seed growers. My seed growers are, first and foremost, they'll tell me what went wrong, and then they'll follow up with what they liked about products. So I'll get a lot of really good information from my seed growers, and then walk in fields myself, and then replicated trials. And then the key, of course, is to share that information with all my growers and retailers to help build confidence. And not just the good stories. Information sharing has to be the good, the bad, and the ugly, so that as a team, my retails and myself, we can work to figure out where a product seems to fit best, or maybe it doesn't fit at all. We've had varieties come through that looked amazing on paper in a chart, on a data package, and then they just kind of flopped when they got out in the real world. So we have killed varieties, and we have to talk about those as well. So last winter, I took a group of retails down to St. Louis to tour Monsanto, and we do some strategic planning when we're down there. And one of the take-homes for me from that planning session with these retails was that they were really asking me to provide more information on how they can be successful with our genetics. Don't just give us a yield chart. Tell us how to be successful with your genetics. Everybody has good stuff. Help us to be successful. So I kind of changed our focus here in Manitoba. And this past year, instead of running 7 yield trials, I ran 3 or 4 more intense trials where I had replicated 30-inch row seeded plots, and then right beside that, solid seeded plots. So then I could start to compare varieties side by side, 2 different seeding techniques, and try and determine which situation worked better for certain varieties. I'm also trying to take more and more maturity photos and notes because varieties perform differently in different latitudes and longitudes. So the more information, the better. From the west, again, we get more pod height questions, so we're trying to take more photos, take more notes on those bottom pods, and see where they are. Disease observations on a year where you have lots of pressure, it's great because then we can build confidence right away whether our product is good or bad. When you have a really good year with no disease, no IDC, no pressure, then it's hard to really be confident in a new product. But so we like to see some pressure to help build confidence. And this picture here is just showing an example. So previous to this year, we were just showing yield charts. Now this year, we're trying to do more maturity photos so we can help tell a story. We have pictures of various varieties, so you can see how they branch, if they're a very slim plant versus if they're a wide, bushy plant, where all the pods are located. We're trying to do more pictures on pod height in different situations to help farmers. And then these are yield trial results from wide rows versus solid seeded, so we can compare varieties and how they do in a wide row situation versus solid seeded side by side. So these are some of the things that we're doing at SeCan to try and help our retails learn more and be more successful with our genetics.
Thanks so much, Brad. If you have a question for Brad, please type it into the chat box now. Tom and Elroy are also still on the line, so if you have a question for one of them that you didn't get a chance to ask earlier, feel free to ask now. Just please let us know who your question is directed to. Brad, how can a retailer really position themselves as a trusted information source on soybean? Can you give us some insight there?
I think for me, it's about having some personal experience. It's about getting out in the field and seeing things for yourself. If you have a strip trial, or if you can go to a strip trial, touch and feel, walk around, look at stuff, and not just what you're selling, but also competitor products, so that you can make some comparisons. And talk about everything, the good, the bad, and the ugly, because one variety won't fit everywhere. So you really need to understand your limitations and know when to talk about those limitations and make sure that you're positioning the best product for that customer.
Do you have any tips for making the most out of the soybean section of the various seed guides that are out there?
Well, I think you always need to make sure that the data is from as close to you as possible. We see some very significant differences on how a product will yield in the Red River Valley versus Boissevain or Yorkton or Redverse. So make sure that the data you're looking at is as close as possible to your region, and that it is over multiple locations. You can't be just looking at 1 or 2 yield locations. You want to have as many as possible. And just check lots of guides, compare notes, make sure you're looking at the public guides like the Seed Saskatchewan and the Seed Manitoba as well.
And sort of touching on that a little bit, how can retailers and growers distinguish good information from maybe not so good information? Any tips there?
Well, it's not that there's usually not good information. It's just make sure that you look at lots of sources and make sure that you're looking at data that's replicated. It's not just one strip somewhere. You want replicated data. If you can, look and see if it was statistically analyzed and see if there is actually a statistical difference between the varieties that are on that chart. That's critical.
Well, that's all we have time for today. So I'd like to thank our speakers, Elroy, Tom, and Brad, for taking the time to join us to share their expertise. As always, thank you for participating, and I hope you found this information of value. Again, I'd just like to thank our sponsors, 2020 Seed Labs, Canterra Seeds, and SeCan for their support. I'd also like to quickly thank our team working behind the scenes for all their hard work in making this another successful webinar, Kyle Dradawani and Teresa Kurdziewicz. Again, this presentation will be made available online at germination.ca very soon. Thanks again, and I hope you have a terrific day. This is Mark Zinkowitz of Germination signing off.